Wishing you all. I'm Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, I wish to tell about Bravais lattice. So, there are various ways of positioning the points in space such that all the points have identical surroundings. So, here we can see this lattice. So, here in this lattice, the lattice points. So whatever the lattice point, whenever you may take any lattice point on this unit cell, on this lattice, it is identical to its surroundings. So if I can take this one, so it is identical to this another lattice point in the lattice. So there are various ways of positioning points in space such that all points have identical surroundings. So these are known as Bravais lattice. So here in Bravais lattice, there are two types. So one is Bravais lattice in 2-dimensional and Bravais lattice in 3-dimensional. So in Bravais 2-dimensional lattice, the points are arranged on a plane. In 2-dimensional Bravais lattice, points are arranged on a plane. So this can be distinguished in 5 ways. So 2-dimensional Bravais lattice can be distinguished in 5 ways. When taking this 3-dimensional Bravais lattice, points are arranged on space. So points are arranged on a space. So here the 3-dimensional space lattice is generated by repeated translation of 3 non-coplanar vectors. In 3-dimensional space lattice, it is generated by repeated translation of 3 non-coplanar vectors. So there are 14 distinguishable ways of arranging lattice points in 3-dimensional. So there are 14 distinguishable ways of arranging lattice points in 3-dimensional space. So these 14 space points, space lattice, are known as Bravais lattice. As these are shown by the Bravais lattice, those called as Bravais lattices. So according to Bravais, the possible types of space lattices in the 7 crystal systems are 1 triclinic, 2 monoclinic, 4 orthorhombic, 2 tetragonal, 1 hexagonal, and 1 orthorhombic and 3 cubic. So according to Bravais lattice, the possible ways of space lattices in 7 types of crystal systems are triclinic, in triclinic 1, and in monoclinic 2 types, in orthorhombic 4 types, in tetragonal 2 types, hexagonal have 1 space lattice, and rhombohedral also 1 space lattice, and in cubic crystal have 3 types of space lattices. So here the space lattices formed by unit cells are marked by these different symbols. Those are first we can see that primitive lattice. So primitive lattice can be denoted with P. Primitive lattice can be denoted with letter P. So in this primitive lattice, it has lattice points only at the corners of the unit cell. So primitive lattice have lattice points only at the corners of the unit cell. Suppose I am taking a lattice . So in this is a lattice, and each point on the lattice is lattice point, as here each point is identical with the surroundings. So when talking about the primitive lattice, so it has lattice points only at the corners of the unit cell. Suppose this is two-dimensional lattice. So here, this is one of the lattice, that is a unit point, unit cell. So this unit cell have lattice points only at the corners, but not in the face or body center like that. So only the lattice points are only at the corners, So this is primitive lattice. So primitive lattice which has lattice points only at the corners of the unit cell. Body-centered lattice. Body-centered lattice can be denoted with I. Body-centered lattice can be denoted with I. So having lattice points at the corners as well as at the body center of the unit cell. So having lattice points at the corners as well as at the body center of the unit cell. Suppose here this is a lattice, so this is only at the corners. So lattice points only at the corner in this unit cell. So it is a primitive lattice. So here body centered lattice, sorry. So here this is also an unit cell. So this is a body centered lattice which have lattice points at the corner. So here in this unit cell, the lattice points are at the corner as well as at the body center of the unit cell. Here we have lattice point and at the corners we have lattice points. So body centered lattice having lattice points at the corners as well as at the body center of the unit cell. So it is denoted with I. Face centered lattice, so it is denoted with F. Face centered lattice, it is denoted with F. So having lattice points at the corners as well as at the face centers of the unit cell. So lattice points at the corners as well as at the face centers of the unit cell. So then we called it as face centered lattice. In the face centered lattice, not only at the corners but also at each face it has a lattice point at the center of the face. Coming to the base centered lattice. In this base centered lattice, having lattice points at the corners as well as at the top and bottom of the base of the unit cell. So base centered lattice, not only the lattice points at the corners but also top of the unit cell and bottom of the unit cell. So it is denoted with capital C. It is denoted with C. So the space lattice formed by unit cell can be symbolized with P, I, F and C. So called as primitive lattice, body centered lattice, face centered lattice and base centered lattice. So here face centered lattice means not only face centered lattice means Here it may have one lattice, here, here and here. So at each face, at each face, there will be a lattice point at the center of the unit cell. Okay, so this called as face centered lattice. Okay, and base centered lattice, the lattice points at the base, at the top and bottom. In this base centered lattice, the unit cell contains lattice points at the corner and also top of the face, center of the top face and bottom at the bottom side of bottom side also. So lattice points at the corners as well as at the top and bottom of the base of the unit cell. So here, so primitive means only at the corner. Primitive lattice. It is denoted with P, only at the corners. Only at the corners. That is lattice points only at the corners. So in this body centered lattice, the unit cells contains is denoted with I. At the corners, lattice points at the corners as well as center of the body, that is center of the unit cell. Coming to the face center. Face centered lattice, it is denoted with face centered lattice denoted with here F. So at the corners, lattice points be at the corners and also at the center of the each face. Next, coming to the base center. So here the unit cell base center is denoted with capital C. This is at the corners, also center of the top and bottom face. So 1, 2, 3, 4. Detailedly we can see here. So we shall take the primitive lattice. In this primitive lattice, if we take simple cubic, so the simple cubic crystal be here. So simple cubic crystal, this is simple cubic crystal. So in this simple cubic crystal, when pointing the lattice points, so here and here at each corner we have lattice points. Each corner having lattice point. So the lattice points are only at the corners, then we say primitive lattice. So in this simple cubic, the lattice points are at the corners only. So it is a primitive lattice. So coming to the face-centered cubic. So face-centered cubic means face-centered cubic means here in this cube, that is it have taken a simple cubic only. So in this cubic crystal, the lattice points are at the corner. The lattice points are at the corner, each corner, and also at each face. So at each face, at the center, there will be another lattice. Okay. So each face, this is face 1. So this is for face 1, and as well as this is opposite side, face 2, and here this is face 3, and this is face 4, and here it is face 5, this one is face 6. So if we take a cubic crystal, the lattice points are not only at the corners, but also at each side of the face center having lattice points. So at each face centrally we have another lattice point. So 6 faces it contains, each face a lattice point. So it contains 6 faces. So at the 6 faces at center there is lattice point. So face centered lattice, not only the lattice points at the corner, these are the corner side lattice points of the cubic crystal. So 1, 2, 3, 4, 5, 6, 7, 8. But when taking cubic crystal, we have 6 faces. So in the 6 face, each face center, at the center of each face, it contains lattice points. So then it is face centered cubic. Coming to the body center cubic, not only the lattice points at the corners of the cube, but also at the center of the body. It contains lattice point. It contains lattice points. So when taking body center lattice, here in this cubic crystal, along with the corner lattice points at the middle of the cube, another lattice point be there. So then it is a body centered cubic. Coming to the base centered. So base centered means only at the top and bottom. So top face, at the center of the top face, along with the corners, there will be a lattice points at the center of top face and at the center of bottom face. It has lattice points. Here, this is base center orthorhombic. So if you are taking orthorhombic crystal, so along with the corners of lattice points here, these are lattice points at each corner. At the top, so at the center of the top, there is lattice point, and at the center of the bottom face there is another lattice points. So this is base center lattice. So primitive, the lattice points be only at the corners, Body center means the lattice points along with the corner, and also it contains lattice point at the center of the body. Face centered lattice in this along with the corner atoms or corner lattice points. It has at each center there will be lattice point at each face. And base centered lattice denoted with C along with the corner lattice points, center of the top and bottom face have lattice points. So here are the 7 types of crystals. 7 types of crystal which have been distinguished by the Bravais. One is cubic. In this cubic, ABC, all ABC, that is we called ABC as primitives. Primitives or fundamental translational vectors. Fundamental translational vectors. Alpha, beta, gamma. These are interfacial angles. Interfacial angles, or we can call as interaxial. Interaxial angles. And collectively we called as lattice parameters. Collectively we called as lattice parameters. So all this called as lattice parameters. Okay, so these primitives, what we are saying, primitives A, B, C, these A, B, C defines the dimensions of the unit cell. These A, B, C defines the dimensions of the unit cell. So here, if we take a cubic, so this cubic, all the dimensions be same. So A is equals to B is equals to C, and interaxial angles or interfacial angles alpha, beta and gamma. Alpha, beta, gamma. So alpha, beta, gamma is 90 degrees. So coming to the other crystal, tetragonal. In this tetragonal, A is equals to B, but it is not equal to C. So these two are equal, but C is not equals to A or B. And interfacial angles alpha, beta and gamma have 90 degrees. Will have 90 degrees. Next, orthorhombic. In this orthorhombic, A is not equal to B, B is not equal to C. So all the dimensions of the unit cell, all the dimensions of the unit cell is different. So A is not equals to B, that is a length. So A is not equals to B length, and this B length also not equals to C length. So all the dimensions A, B, C are different. Coming to the interfacial angles, alpha, beta, gamma have 90 degrees. This crystal, alpha, beta, gamma is equals to 90 degrees. Next, rhombohedral. So in this rhombohedral, the dimensions A, B, C, all the dimensions are same. So A is equals to B is equals to C. And interfacial angles, alpha is equals to beta is equals to alpha is equals to beta is equals to gamma, that is not equals to 90 degrees. So interfacial angles are not equals to 90 degrees. So can clearly understand by the picture, observing the picture. Next, hexagonal. In this hexagonal, A and B, both dimensions be same, but it is not equals to length of the C. So then the interfacial angles alpha, alpha, beta or 90 degrees and gamma is equals to 120 degrees. So interfacial angles alpha is equals to beta, that is equals to 90 degrees and gamma is equals to 120 degrees. Next, monoclinic. So in this monoclinic, all the dimensions are different. So A is not equals to B, B is not equals to C. So A is not equals to B, B is not equals to C. So interfacial angles alpha is equals to gamma is equals to 90 degrees, but it is not equals to beta. It is not equal to beta. Coming to the triclinic, in this triclinic, A is not equals to B, not equals to C. A is not equals to B, not equals to C. In interfacial angles, alpha is not equals to beta, that is not equals to gamma, is not equals to 90 degrees. So these are the 7 crystals. These are the 7 crystals that Bravais have taken and distinguished the space lattice in 14 ways. So here this is the picture which we can clearly understood that 7 types of crystals showing 14 ways of arrangement of lattice points. So here is showing crystal system. So type of the crystal system and how many number of lattices are possible and the lattice type, what lattice type it is, and the restrictions on lattice parameters. So how the lattice parameters are in that lattice. This is lattice symbols. So lattice symbols means is it primitive or body centered or face centered lattice, like a lattice symbols. And examples. So what type of crystal? So example which can shows this type of space lattice. So first one, cubic crystal. Cubic crystal. So it gives 3 lattices. It gives 3 lattices. Those are simple cubic, body centered cubic, face centered cubic. So simple cubic crystal, body centered cubic crystal, face centered cubic crystal. So 3 types of lattices can be shown. And here in simple cubic or body centered cubic, so whatever may be that, the cubic have the nature of all sides, that is dimensions be the same. So A is equals to B is equals to C. So in that case, A1 is equals to A2 is equal to A3 and interfacial angles is equals to 90 degrees. So alpha is equals to beta is equals to gamma, that is equals to 90 degrees. So it shows lattice, that is primitive lattice, and this one is body centered and face centered lattice. Example we can take copper, Ag Argentina, ferrous, sodium chloride we can take as an example for this type of space lattice. And second one is tetragonal crystal system. So it gives 2 space lattices. One is simple tetragonal Another one is body centered tetragonal. Here the dimensions are A1 is equals to A2 is not equal to 3. Alpha is equals to beta is equals to gamma, that is equal to 90 degrees. So it shows primitive lattice and body centered lattice. And here titanium dioxide we can take as an example. Next, coming to the third crystal system, orthorhombic. Orthorhombic gives 4 types of space lattices: simple orthorhombic, body-centered orthorhombic, face-centered orthorhombic, and end-centered orthorhombic. So, end-centered orthorhombic is nothing but base-centered orthorhombic. Here, the dimensions of A1 is not equals to A2 is not equals to A3. That is, all the dimensions are different in this crystal system. And interfacial angles, alpha is equals to beta is equals to gamma, that is equals to 90 degrees. Here, primitive lattice, body centered lattice, face centered lattice, and this one is base centered lattice or end centered lattice. So we can call it base centered lattice, or also we can call it as end centered lattice. Both are the same. So here we can take examples of gallium Fe2C. Then coming to the monoclinic. So monoclinic have 2 types of space lattices: simple monoclinic and end-centered monoclinic crystal. So here the dimensions of A1 is not equals to A2 is not equals to A3. Alpha is equals to gamma, that is equals to 90 degrees, but it is not equals to beta. Here it shows simple monoclinic type of crystal, that is primitive lattice, and it is base centered lattice type. So for example, we can take gypsum as an example. Gypsum as an example. Next, triclinic. A triclinic gives 1 space lattice, that is simple triclinic, and the dimensions are A1 is not equals to A2, that is not equal to A3. Alpha is not equals to beta, that is not equals to gamma. It shows primitive lattice type. And for example, we can take it as Cr2O7. And sixth one, trigonal or rhombohedral. So it gives 1 space lattice, that is simple trigonal. Dimensions are A1 is equals to A2 is equals to A3. Alpha is equals to beta is equals to gamma, that is less than 120 degrees but not equals to 90 degrees. So this is primitive lattice type, and they can take the example AS and BS. So that is arsenic and next, 7th one, hexagon. 7th crystal system is hexagonal. So it gives 1 lattice, space lattice, that is simple hexagonal. Alpha is equals to beta, that is equals to 90 degrees, but gamma is equals to 120 degrees. So both the angles alpha is equals to beta, that is 90 degrees, it shows 90 degrees, but only the gamma will be 120 degrees. The dimensions are A1 is equals to A2, but A3 is not equals to A2. So A1, A2 are same, but A3 is different dimension, different length it has. The lattice symbol is primitive lattice type. Here take as an example of zinc and magnesium. So these are the 7 types of crystals, and these systems shows various ways of arrangement of atoms. So that can be distinguished in 14 ways by the Bravais lattice. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.